Okay. Let's go down to vertical asymptotes then. So vertical asymptotes, we're going to go from the reduced form, meaning -2 isn't a vertical asymptote because it's a whole. So of my reduced form, we set the denominator equal to 0. So we set x plus 3 equal to 0. This has a vertical asymptote at x equals -3. And looking, that matches what I see on the graph. There's that vertical asymptote. Okay. I would like to do slant asymptotes on Thursday. You're going to see them on Edgenuity tomorrow as well. I only reference Mr. Spelman because I know what he usually talks about in class. He normally talks about these in class. It's an asymptote that's on an angle. Okay. We'll talk about them again today, or like I said, Thursday. But I want to focus on horizontal asymptotes. So here's how you tell. You take the degree of the numerator and over the degree of, well, find the degree of the numerator, find the degree of, this should say the denominator. I don't know why it says that. So it should say degree of the denominator. All right, if the numerator has a smaller degree than the denominator, then no matter what, it's going to have one at y equals 0. So let's look at our case. Go to the original form. What's the degree of the numerator? 1. What's the degree of the denominator? 2. Is the numerator have a lower degree than the denominator? Yes, that's this case 1. What it's saying is there should be a horizontal asymptote at y equals 0. Does it look like that's the case? In a second, I'll give you case 2 and case 3 so you can see. I'm just an example of that. All right, slant asymptotes, that would be if the numerator is greater than the denominator. And like I said, we'll talk about those on Thursday. X-intercepts. This is where we had to do our cutting here. Find your x-intercepts from your factored form and set the numerator equal to 0. So up here, my factored form was this one, and the numerator was x plus 2, okay? So normally, this would be at x equals -2. However, why am I putting a star in this specific case? It ends up, in our case, that it's a whole. So what we're going to do here is we're going to say as long as it's not a hole in the graph. So if you're looking at our graph at x equals -2, normally that would be an x-intercept, but there's a hole there, and so it is now. Okay. Determine the end behavior. The end behavior is the same as the asymptotes. Okay, so all I'm going to just tell you is before where they blew up infinity and negative. What? Zero. So I'm going to write here. Some books they don't call these horizontal asymptotes, they call them end behavior asymptotes, in fact. So. This should be horizontal. Alrighty. we feeling? You're so quiet, it's hard to tell with you guys. Are you feeling all right with this stuff? Okay, I want to just show you a case where the numerator and we're not going to do all of these things, but some of a case where the numerator and denominator are the same degree, so we can talk about the asymptote for that. All right, so let's make up an example. See what I have. I want to do them where they're the same. Okay. So let's just go ahead and identify just the asymptotes for this one. So, yeah. So let's first talk verticals. If I asked you to find the vertical asymptotes, you would want to factor the denominator. In fact, I would actually factor both just for the heck of it. This factors in x to x minus 2, agreed? The top factors into x plus 1, x minus 1. That's not going to do anything for us for our questions, but if I asked for x-intercepts, then I'd want to set those equal to 0. I didn't. So vertical asymptotes, I have them memorized, but if you look at your foldable, it says in factored form, reduced form. Is there anything I can cancel, by the way, on this one? No, so they're not, there's no holes in the graph. They are the zeros of the denominator. What would make the denominator 0 here? X equals 2, x equals negative 2. Okay, and then, yes, Ramsey, you are correct. I compare the degrees, go back to the original form. The degree of the numerator and denominator are the same thing. So when that happens, numerator equals denominator, you're going to have y equals the ratio of the coefficients of the leading terms. All that means is you divide those leading coefficients. The leading coefficient here is a 2. The leading coefficient here is a 1. 2 divided by 1 is 2. So the horizontal asymptote would be y equals 2. I'm going to just pull up the graph and confirm what we see. I always find it easier to type in the original form. It's less work. Okay, do you see that this is the 2 and the negative 2 for the verticals, and then this is the y equals 2. In fact, you could even put it in if you wanted. There's the y equals 2 for the horizontal. Make sense? Okay, so what we're going to do then